Okay, so algebra, we're into 410. We're doing about the same thing. So I'm going to work through problems that are in the book using a chart that I handed out. The charts that I handed out, I have the same information at the top, but it's probably worth a repeat. That rate measures how fast things go. So if the question says how fast, that's a rate thing. There's usually the word per in those. Time measures how long something takes. So if they're asking in a question how long, that's a time question, hours, minutes, seconds. Distance was how far, miles, meters, kilometers, that kind of thing. And the other thing you have to do is make sure the words are consistent. If it's hours here, miles per hour, if they drop you some minutes, we have to do some conversions. So that happened in last night's homework once or twice, that 30 minutes had to turn into who? A couple times. What was it? Half an hour. So if we still might have to do that kind of work on things. But I'm working from page 172 is where I am. There's an example 1, and I just have my own table. They have their table too, but we'll just follow along. So across the top I listed rate, time, distance, as always in that order, because that lets us do what when we multiply, I gave it away. Lets us do what with the table when we move across? Multiply across. So if we go rate, then time, then distance, always in that order, we're always able to multiply across that we're used to. So example 1, we read. 45 miles per is a key word, hour. What's that going to pencil us in?
Rate.
That is a rate. 1 hour later lets us fiddle around with the times one way or another. Second car leaves, blah, 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 54 miles per hour. That's going to be a rate. So the rates will be 45 and 54. I like to put headings on the left edge just so I know what I'm talking about. So I might say like first car to leave had the 45, second car to leave has the 54, something like that, just so I know who's who. There's 2 correct ways to do the times. If the one car left 1 hour later, that means the other car left 1 hour earlier, if you want to look at it that way. Both of these time boxes would have to do with the letter T, but there'd be 2 correct ways to set it up. One of the boxes could be a T and do what to modify your T? Plus 1 in one direction, or it could be a minus 1 in the other direction. You just have to make sure you do it the right way. I'm going to do my bottom second car to just be a T. So if I go my second car to leave being the T, so 54 is lined up with T, what would be the correct way to do the 45 box then?
Distribute.
T plus 1 or T minus 1?
Plus 1.
T plus 1. So first car 45 would get a T plus 1 if the second car 54 got a T. Question about setup from paragraph. Generally, you're going to be able to fill those 4 squares and then multiply across. So the top distance box, if we distribute, would be, it is. The bottom box would be 54T. And then there's distance choices to make. Yesterday, some of the equations, we did distance box equal distance box. For other problems, we'd have to add the distances together to equal some other number. Is this one where the distances are equal? Or is this one where we're adding them up to equal some other number?
Equal.
Equal. What's one way we know we can't be adding them up to equal some other number? Just common sense. Why is there no chance we should be adding these up to equal some other number?
Because they're the same distance.
Well, that's true. But if you went looking in the paragraph for another number, there are no other numbers. We used all the numbers. So if we had an unused number, sometimes that's a signal maybe you do need to add those up to equal that unused number, but we don't have any unused numbers. The other thing we have by common sense is they left the same place and they're arriving in the same place. So they have to be going the same distance. That I 100% agree with as well. But let those equal each other, and then do some opposites, solve it out. Time would be
Be 5.
it is. Algebra will get us a time of 5, which may or may not be the answer. Does anybody need help with the algebra leading us to 5 before we talk about whether that is or isn't the answer? Okay, so here's what they could ask you. They could ask you, how long did the second car drive, which is 5. They could also ask you, how long did the first car drive, which would be,
Wait, the first car?
yeah,
45.
how much time the first car was driving. If they ask how much time for the second car driving, it's 5. But if they ask how much time for the first car driving, 6. Because what did we know about that first car?
1 hour later.
Left an hour more driving. They could also ask you for distances. If they asked you for a distance, you'd have to go to one of those distance boxes and multiply. Either the 54 times the 5 or the 45 times the 6. Those will work out to be the same, so it doesn't really matter which one you would do. But if they ask you for a distance, we'd have to go and do a multiply. So what did they ask us for? Check the paragraph.
Second car overtake the first
Second car time. So that is the
5.
5. And we were a winner. Question about that one? Okay, so let's go to example 2. Example 2 says 2 hikers walk in opposite directions. They start from camp at the same time. The westbound hiker is quicker. He's going to do 2 more for his rate than the east hiker. So let's do the rates. So I labeled west-east. The west guy is quick. We don't know either one. What would be one correct way to do the rates if the west guy is quicker by 2?
T plus 2? Or
I'll go R plus 2.
R plus 2. Okay.
For west or for east is the R plus 2.
West.
That works. I could do a west of an R plus 2. I could do an east of an R. If somebody wanted to argue with him, there is a correct argument. It's not better than what he did, but it would be a tie. If you did the west as an R, what could you do the east as?
Minus 2.
R minus 2. Just as good. It's not better, it's not worse. It's just different. Times. If the rates are variables, the times have to be numbers. They can't give you 2 variables in the same problem until they take you to Algebra 2 and expand on your knowledge. As long as we're working Algebra 1, there's only going to be 1 variable per problem. So since the R's are in the rate group, the times, we just have to know the time, straight out number. What number is the time?
Hour and a half.
Hour and a half. 1.5, 1.5. So both times 1.5, 1.5. Question about doing that? Then multiply across. If 1.5 distributes R plus 2, that'll make
Three.
the 3's in there, yeah. 1.5 R plus 3.
1.4 R plus 3. Okay.
Then the other box is just 1.5 R. Question about table. Distances. Again, what's our choices with distance? Some of the questions, what do we do with distance boxes?
Like, it would be equal.
They're equal. Other questions, we
Like, add.
them to equal what? Where do we pull a number if we're going to add them to equal who?
The 15.
Yeah, like a stray number from the story. So in this one, I'm suspicious we should add them because there is a stray number in the story this time. So if you have a stray number in the story, we might want to think about adding them even more than we usually do. And then use a little bit of your common sense. These two hikers left at the same time. The one went this way and he's fast. The other went that way and he's slow. Would their distances be equal? No, the fast guy's going to definitely go more distance. So it would make no sense for us to try to make those distances be equal. This is a story where we want to take the one, add the other. It's going to equal the 15 because they're telling you they started in the same position, ran away from each other, and they end up 15 apart. So this plus that equals 15. So we're looking at 1.5r plus a 3 plus another 1.5r equals a 15. And then let's solve for some r's. Combined like terms, you'd be up to
3r plus 3.
3r plus 3 equals 15. Do an opposite.
Subtract 3.
Subtract 3 down to 12. Then
Divide 3 into
down
12.
to
4.
4 is maybe the answer. Algebra is correct. 4 is necessary. We have it. We're happy, but maybe that's the answer. Maybe it isn't. Question about getting the 4. The 4 is the R. The R box is in the east hiker line. So if they ask you for the rate of the east guy, it's 4. But they could also ask you for the rate
The west guy.
of the west guy, which is 6. Or they could ask you for the distance that these guys were going on their own, in which case you pop over to the distance boxes and you'd have to multiply. So what did they ask you? Did they ask you one rate, the other rate, both rates, distances? Both.
Each.
Both rates or both distances?
Rates.
Both rates. So we fire back with who and who? What are our numbers for our answer, and then we win?
Would 6 be the
6 is one,
west, and then the 4 be the
4 is the other. 6 and 4, you fire back both rates. Yep. Something about that one. Flipping a page to find a new story. Example 3, we're up to 174. We're going to the beach and then we're coming home. So I'm going to label across the top rate, time, distance like I always do. Coming down the left side, I'm going to say like go there and come back, or to and from, or something like that. 45, what's that?
Rate.
That's a rate. Rate there, rate back.
Right there.
That's the rate going there. So the to or the going there or however you labeled it, the first part of the trip, the rate's 45. 54?
So get back, right?
Yep, that's the coming back rate. So 45 stacked on top of 54. So since the rates are numbers, it stands to reason that the times are going to have to be letters. There's got to be a variable in here somewhere. Is it good or bad news that they mentioned 20 minutes? Minutes, happiness or sadness?
side.
Sad. Since they were committed to hours, 45 miles per hour, 54 miles per hour, we're committed to hours, the 20 minutes has to turn into a piece of an hour. So you could put 20 at first in your mind on top of
100. 60.
60 what?
Because 60 is an hour.
Yeah, 60 minutes is an hour. So 20 on top of 60, but then reduce it. Always reduce if you can.
So it'd be a third.
It'd be a third. So it says the trip home is quicker, which makes sense because they drove faster. If the trip home is quicker, what would the coming home box have to do with t's and thirds?
Would be t minus a third.
It is t minus a third. And the time to it would just be a t. And then we can multiply across. 45 times t, just put 45t. If 54 distributes, 54t minus Quick way to do 54 times a third is just 54 divided by 3. That works. It goes evenly. 54 divide 3
Is it 18?
is 18. So 54t minus 18. I confidently say we can't be adding these up to equal another number because there isn't another number. If we think about it just to be sure, going somewhere and coming back, does it make sense that the distances should be the same? You go there, you come back?
Yeah.
Yeah,
Yeah.
that makes sense. So let the one box equal the other. 45t equals 54t minus 18. If you get the t's to the same side, 54 and 45 battle it out.
Negative 11?
Warm negative, but not 11. A little bit of borrowing on your subtract there. 54 separation from 45.
Subtract it.
Yeah, we're subtracting that. Use fingers if you have to. 9 is correct. So we got like a negative 9t equals negative 18. Divide, time,
Maybe 2?
2. So if they asked for the time to get there, it would be a 2. If they asked you for the time to get back, you'd have to take the 2 and subtract the third. But if they asked you for a distance, you'd have to step to the distance boxes and multiply, and you could use either box because the distances were the same. Did they ask you for a time, or did they ask you for a distance? Distance, how far? Far is a distance word, so go to a distance box and do a multiply. I would suggest 45 times 2 is your easier multiplication than the one with the fraction.
Should be 90?
It is 90. You can use either box when the distances are the same, but just like be smart about which one you pick. Question about those three? There were no new tricks there. I told you they'd have a new trick or two up their sleeve in this section coming. It wasn't it yet, so we'll flip the page and keep going, because maybe it's coming. 174, they're doing these class problems. You know, and maybe the tricks up their sleeve is saved for tomorrow, because I don't see any tricks on my class problems either, unless I'm missing it. But let's just keep going. So for class exercise 1, I'm going across the top, rate, time, distance. I'm going down the left, Smiths and Dupree's. Do you know the Smith rate?
50?
50 is true. Do you know the Dupree rate?
Yes. 70.
70 is true. So since the rates are numbers, the times have to be variables, because we need a variable in here somewhere. There's two ways you could set up the times correctly. What in the paragraph do we know about the times? We don't know exactly a number, but we know at least a little bit of a relationship.
The Dupree's left 3 hours after?
Yeah, the Dupree's left 3 hours later because they're speedmeisters. The Dupree's are flying 70 miles an hour. So the Dupree's left 3 hours later. There's two correct ways you could deal with that 3 in the time columns. What's one option for time setups?
Did T plus 3 for Dupree?
No. Second choice.
T minus 3?
We could go T minus 3 for Dupree,
Oh.
and then a T for Smith. If you want to do a T plus 3, the T plus 3 would have to be for Smith. The T would be for Dupree. If we're going to have the fast people catch the slower people, we need the slower people to get more time. Because what would happen if the fast person, the fast driver, got the head start? What would happen in the real world?
They would get there first and the slow one
The slow one would never see him again. So make sure on these catch-up, head start questions, always make sure that the lower rate needs to receive the higher or lower time. Lower rate gets the higher time. Otherwise, they'll never be seen again. Make sure the higher rate, likewise, gets the lower time. That's how they can meet up with each other again. Don't ever give the fast people the head start, because that's you're going to get weird answers. I bet you'd probably get a negative answer. It'd be like a time machine problem. They'd only meet each other by going back in time somehow. Question about how that's set. Let me go ahead and set the next one up, because I feel like once you, correct me if I'm wrong, but once we get those first 4 corners set, are you pretty good at going across and pretty good at setting up the equation? It's probably just getting this stuff set up that's the biggest issue. Agreed? So let's practice that the most then. So let me go down to class exercise 2. We'll double back if we have time, but we may not have a ton of time. So class exercise 2, I'm up to page 175 now. I'm going across the top, rate, time, distance. And then down the left, I've got a north and a south is what I'm going to label mine, just skimming the question. I see a north plane, south plane. So rates. Do we have numbers for rates, or are we going with some R kind of stuff?
Numbers?
Nope. Got to go with some R kind of stuff. What do we know about the rates? We don't actually know an exact rate. We just know a relationship. Anybody pull that out of the paragraph? What's the rate relationship?
Same time.
Well, we're getting ahead of the game. I'm scanning out the rates first.
Well, the north plane is 100 faster.
North is 100 faster. So we don't know the north, we don't know the south, but we do at least know the north is 100 faster than the south. So there's 2 right ways you can do that. You can be adding 100 or subtracting 100. You just have to get them in the right slots, in the right system. So if the north is the fast, what's one correct way to set up a rate scheme?
R minus 100?
For who? We can do it that way, but it has to go with the right one.
North?
South. Because the south guy is slow. So you want to make the slow guy get the subtract, you want to get the fast guy get the add. So we could go north of an R, south be R minus 100. You could also have gone south as an R, and then north would be
R plus 100?
R plus 100. Since the rates were variables, the times have to be,
There?
numbers are variables.
Numbers.
Numbers. So we've got to grab a time number. Carter's correct. The time was the same. What's the number for it? 5. So go 5, 5. Each block's 5. Question about setting that up? Okay, let's go down one more. Go to class exercise 3. I got rate, time, distance. It looks like we're going there and coming back. So we have a go there and a come back. Do we know the rate for going there, or is that a variable?
It's a number.
It is a number. Which number?
25.
25. Do we know, or can we figure out the rate for coming back?
No.
We don't know it right now, but we can figure it out. But what do we know about coming back rate?
30 minutes less to...
No, that's a time.
Oh.
Coming back rate. Look for the slash or the word per. That'll spot you your rates. 5, but he's not traveling 5. He's traveling 5 faster. So what's he traveling?
30?
30. How'd he do that?
Because you add.
Yeah, 25 there. Coming home, he's 5 faster, so add 5 plus 25, so there's 30. So the go there rate, 25. Come back rate, faster, 30. So if the rates are numbers, the times have to be variables. So they both have to do with t's. We could either do it with adding or subtracting, and using what number?
30?
Sort of.
A half an hour.
Half an hour. Yeah, the minutes, they're always going to try to fool you with minutes. We'll make that 30 minutes turn into half an hour. So there's maybe a t plus a half. There's maybe a t minus a half. It depends on your mood. There's 2 right ways to do it. You just have to get it right. There's definitely a t. So pick one of them to be t, and then the other one might be t plus or t minus a half, depending on which one you're doing. A thought?
So t minus a half to return home?
Yes. Because we came back faster. That's going to take less time. So coming home is t minus half. Getting there must be t. Also correct if you did coming home t and getting there t plus a half. That's just as good. Class exercise 3. I got a rate, time, distance. I got a north and a south again. Do we know the rate for north exactly?
Yes. No.
No. What do we know about rate for north?
It's like 5 miles faster.
5 more than the south. So these both have to do with r's. One correct way would be r minus 5 here. Another correct way is an r plus 5 there. Somebody's got to just be the plain r. Never do them both, because if you add 5 to one and subtract 5 from the other, what's the actual difference? If this one lost 5 and this one gained 5, that's not 5 away anymore. That's no, there's a big difference.
The dude has 5.
There's a difference of 10. If one lost 5 and the other one gained 5, that's a 10 difference. Don't do that. We just need to do a single 5. So somebody's an R with a 5. Add or subtract it. Anybody a thought? Again, the north is fast.
Is north r plus 5?
North can be r plus 5 if south is r, yes. North could also be r if south is r minus 5. You do whatever you want with that. Since the rates are variables, the times have to be numbers. So we go hunt that number down.
Three and a half.
3.5. Mm-hmm. So r minus 5, or however you did the r's, but both times 3.5. All 4 of these tables, we're going to run out of time. We're down to like a minute, but all 4 of these tables, you don't have to finish them. If we had more time and we did finish them, we'd multiply across. For number 4, I would add them up to equal another number, because I have another number. So there's a 399 lurking there. They also had the trains leaving and running away from each other. That's a dead giveaway. If the trains leave and run away from each other, you're going to add up their distances. Likewise, which other one would we add the distances together other than 4? Because the stuff ran 2. They ran away from each other, and we have this stray number in there. Homework, we're working 175. It's a 1 to 7. Just do what we were doing. Make the table, make the equation, solve it up, interpret it, the whole bit. 175, 1 to 7 is the name of the game today. And then maybe tomorrow's the day that there's a new trick up our sleeves. Yeah, I have in my notes tomorrow that they have a new trick up their sleeve tomorrow. I have to do one or it becomes impossible. But there weren't really new tricks up their sleeve today.